everyone. Welcome or welcome back to the Next Level FAANG YouTube channel, your one-stop destination for all upcoming FAANG interviews. So today we'll be solving another very interesting problem, which is called the reverse words in a string 2 problem. So this problem is another premium problem, by the way, and we have been solving a lot of premium problems lately on this channel. So make sure you do hit that subscribe button for all the exclusive content coming your way. So let's get right into it. So we have given a character array, which is called S, and we have to reverse the order of the words. So a word is defined as a sequence of non-space characters. The words in S will be separated by a single space. And our code must solve the problem in place, that is, without allocating any extra space. So basically, the question says that if we have the input, the sky is blue, which are like four words in this array. So we have to reverse the order of the words. Like the blue word, which is occurring the last, has to occur in the first place. And similarly, is the second last has to occur in the second place, and then sky, the. So the sky is blue becomes blue is sky, the. And for just a single character, it remains the same. So this is what the problem space is. The problem is fairly easy to understand. So now let's get right into the explanation part. So the goal of this problem is basically to reverse the orders of words in place in a character array without allocating any extra memory. The input is the sky is blue, output has to be blue is sky the, which we understood right away. So the brute force approach, if we were allowed to, let's say, have extra memory, would be like we would have just extracted all these words in another let's say array, and then we could have placed it in this manner so that we can get the output, final output as blue is sky the. That has been a hassle-free approach, but it would have been like a linear time complexity solution, but it will also take like a linear big of n space complexity as well. So because we cannot use any extra memory, let's see what other approach we can use. So we can reverse each word individually using two pointer swaps. Like each word we have like the sky is blue. Individually, we can reverse each of these words. Like the will become EHP, sky will become YKS, and so on. Next, what we can do, we can reverse the entire array. So if you try and understand it character-wise, you will be able to visualize like if we reverse each word individually and then we reverse the entire array, the words will actually land in the reversed order which we need as output. So now why this works? So reversing each words, it fixes the letter order inside each word. Like I just discussed, like THE will become EHP. So when we reverse the order, it will become THE again, but with uh, while occurring at the end of the array. And we're reversing the whole array, then flips the sequence of these now corrected words. So both these operations are big O of n and done in place. So there's no extra buffer needed. So it will be like an in-place solution without utilizing any extra memory. Sounds fairly easy to understand, right? So now let's understand it more using a dry run of the example we have. So in the first pass, we are reversing each word. So let's say in this case, we have EHT, which is the reversed version of THE, which is the. So for the word one, we'll encounter it using the first space. So we'll make sure that whenever the first space occurs, before before the first space, we have the first word of the array. So indices 0 to 2, which is the, will be written as EHP after the reversal. Similarly, the sky will be reversed at YKS, making sure that it occurs, it also has two spaces in between which it is actually lying. So for sky, we have YKS. Next, it is. So we have SI, the reversed version. Blue is EULB. So this is what we get after the entire pass. So we have the entire array in a reverse order of each of the words which are occurring in the order in the array as well. So we have like EHP, YKS, SI, and ULB. So this is the board after pass one. This is the output after pass one. So reversing the entire array. So now if we do a full reverse of this, like B will be first, then we'll have L, then we'll have U, then we'll have E. So see how we actually get the output which is required, right? Having the E, like reversing each character and then getting this output will give us a full reverse and which is actually needed as the output. So reading left to right, we'll have blue is sky the, which is the desired outcome. So the prime complexity again, one pass to reverse each word. So we are going through each word, so it will be big O of n, and one pass to reverse the whole array. So it will be another big O of n operation. So combined, it will be big O of n again, which is the dominant here. And then we have space complexity, which is constant because we are doing it in place. Swap only and constant extra space. So this is the entire approach. It was fairly easy to understand. We just we reversed each word. After reversing each word, we just reverse the entire array to come up with the desired output. Now let's look into the code. So here we have the function to reverse the words in a given character array. So we first get the size of the character array to make sure that we are not computing the size again and again. So we iterate through the array to find words and then reverse them. So we are iterating from the start to the end. So if whenever we have encountered a space, so a word will be found, we'll immediately reverse it. After reversing, we'll update the second word or the next word, immediate next word. Else, if we have reached the end of the array, let's say the end is now n minus 1, which is size minus 1. So the last word is found and we'll reverse it as well. So we'll reverse it as well. So after reversing all the words individually, the entire array needs to be reversed. So we are reversing the entire array to achieve the final output. Now we also have the helper function of reverse. We're not using any inbuilt function. So we are swapping the characters from both the ends, moving towards the center. We are having two pointers for that. We are swapping each and every letter and this incrementing the ith pointer and decrementing the jth pointer. So this was the entire problem. I hope you enjoyed the solution. The time complexity of the entire problem was bigger of n, and we were able to achieve it in constant space as it required in the problem. So I hope you like this video. Make sure you do subscribe the channel and hit that like button. And do stay tuned for all the premium content coming your way. Thank you so much.